Thank you for attending our presentation. I'll introduce our paper, Uncurated Image Text Datasets, shedding light on demographic bias. Recently, the increasing use of large uncurated datasets raises concerns about societal bias. However, demographic annotations are scarce for societal bias analysis in visual and language tasks. To address this problem, we annotate 6 demographic and 2 contextual attributes for personing images from GCC dataset. Also, we conduct a comprehensive analysis of the annotations, and the results show that GCC presents big imbalances on the demographic attributes. Moreover, we conduct evaluation of bias in prevailing visual and language tasks. These downstream tasks showed evidence of different performance for different demographic groups. It's known that even small but manually annotated datasets are affected by societal bias. And this problem may be getting worse with data crawled from the internet. These large and uncurated datasets simulate models being trained on hundreds of millions of samples. However, the larger the training set, the less control over the data, leading to a higher risk of societal bias. Societal bias analysis in visual and language tasks poses 2 major challenges. Firstly, there is a lack of human attribute annotations for large datasets. Secondly, demographic annotations are scarce and only exist for a few datasets and attributes. The contribution of our work as follows. We annotate images in a large-scale visual and language datasets to facilitate analysis, evaluation, and mitigation of bias in visual and language tasks. To address this, we annotate images in the GCC dataset, comprising 14,275 in the training set and 4,614 in the validation set. We use Amazon Mechanical Turk, which is AMT in short, to obtain 4 demographic and 2 contextual attributes for each person in the images. With up to 6 attributes per person, we conduct a comprehensive analysis of the distribution of demographic attributes on the GCC dataset. The annotation process consists of 2 parts, region selection and crowdsourcing. In the region selection process, we run an object detector to detect regions with objects. We then filter out regions that do not contain a person, depict multiple people, or are not photographs. In the crowdsourcing process, every selected regions are annotated in 3 rounds by 3 workers via AMT. Our annotation process involves a total of 84 workers. From the demographic statistics, we observed that the skin tone of the workers is predominantly light, and most of the workers are from the US. In order to measure what extent attributes are equally perceived by different people, we compute the inter-annotator agreement with 2 metrics, a consensus ratio and Fly's kappa. The results show that among all the attributes, gender has an almost perfect agreement and highest consensus. In contrast, skin tone and emotion have the lowest agreement but still well above chance. From our analysis of the annotated attributes, we found that all the attributes are imbalanced and skewed towards certain dominant classes. For age, the predominant class is adult, while for gender, the gap between men and women is 28.5%, and it is bigger in skin tone and ethnicity. As per contextual attributes, the most represented emotion is neutral, followed by happy. For activity, the most common classes are posing and other. To further explore the data, we cross-check gender with contextual attributes. By analyzing region-level emotion statistics per gender, we found that women tend to appear happy, whereas men tend to appear neutral. This finding aligns with gender stereotyping of emotions in psychology. In addition, we analyze how the regions of the different demographic classes are presented in the GCC dataset. The figure shows an average of the area and the distance to the image center per class. The most noticeable disparities are in the attribute age, with senior and baby being the largest regions and child the smaller. In contrast, gender regions do not present big differences in size and position. Ethnicity presents a large variance, with the Southeast Asian being farthest from the center and white the largest one. With phase annotations, we evaluate societal bias in visual and language tasks. We evaluate image captioning models, OFA and ClipCap with leak metric. Higher leak values indicate that the model amplifies bias. Our results show that both models amplify bias with respect to the original dataset, excluding OFA in skin tone. Surprisingly, despite being often under-investigated, age exhibits the highest bias according to our evaluations. Lastly, we analyze the demographic representation on stable diffusion. We use the captions that come with each image in the GCC dataset as prompt to generate an image for each original image in GCC. By analyzing the generated images, we observed that gender-neutral prompts often result in images predominantly depicting white men. Thank you all for listening. If you are interested, please also check our work on bias mitigation in image captioning, which is also presented at CVPR this year. We are looking forward to your questions in the poster session. Thank you very much.